So now we're going to use the definition of the derivative to find the slope for the tangent line. Whenever problems talk about a tangent line, you can use the derivative for finding the slope. There's two forms for finding the derivative when using the definition. I'm going to use the form that would say take the limit as x approaches a, or in this case the number 2, and then it's basically slope is rise over run, so I need to subtract the two y values and then subtract the two x values, and there's the rise over run. And now I need to actually substitute the function, the square root of x minus 1 in here. So we've got the limit as x approaches 2, and we've got the square root of x minus 1 for the function. And next, substitute a 2 into the function, so that's going to be 2 minus 1, so we've got the square root of 1. And then the denominator is still x minus 2. As you can see, if we were to substitute a 2 in, we would have division by 0, so that's not good news. As well as we would have in here a 1 once you simplify it, so we'd have 1 minus 1 on the top, which means it's undetermined form. So we need to use some algebra to simplify this. We can eliminate this radical by multiplying by the conjugate, which is the square root of whatever, and instead of using minus 1, use plus 1. And since that was done for the numerator, you also have to multiply the denominator by it. So when using the conjugate, you multiply the first one times the first one. The radicals will be eliminated, leaving only x minus 1. And then, so we've got the first one times the first one. If you were to multiply the middle terms, you would get negative of the radical and positive of the radical, so those two would cancel. So the only other thing we need to multiply is a negative 1 and a positive 1, which is negative 1. And for the denominator, don't multiply it out, just rewrite it as x minus 2 in parentheses multiplied with this radical and a plus 1. As you can see, this now becomes x minus 2, which is going to cancel that x minus 2, which is eliminating that division by 0. So when we cancel, we would be left with a 1 on top. This would be canceled, so we're canceling all of this with all of this. And what's left is the square root of x minus 1 plus 1. And now substitute in a 2. This is going to become the square root of 1 plus another 1. So the slope is 1/2. So what we've got is, this is the slope of the tangent line. And we can use the point slope formula as long as we have a point and a slope. So there's the slope, there's half of the point, we just need the other half, which is the y value. So if we substitute a 2 in here, then we would get that y is equal to a 1, and now use the point slope formula. So it's going to be y minus a y value is equal to the slope times x minus the x value. And then if we simplify and put it in slope-intercept form, it would look like 1/2 x, and then if we distribute this, it's going to be a negative 1. And if you add this to the other side, it would become a positive 1, which is going to cancel that negative 1. So it looks like we're done. And as with so many things, we can use the graphing calculator to see if that looks right. So first of all, graph the original function, which is the square root of x minus 1. And let me change the window. We need just say 0 to 10. We don't need any negative values. The same with the y values. 0 to 10 should be fine. And there's the square root function. So what's happening is at x equals 2 and y equals 1, this point right here, we should be able to graph the line y equals 1/2 x, and it will basically just graze the graph right at that point. So if we graph 1/2 x as well, and then take a look at the graph. So the line goes through 0, 0, it goes through, it hits the graph at this one point, and then continues on its way. You can even zoom in a little bit in that area to see. There goes the graph, and then there goes the line, and if you zoom in at that point, that's the only place where the two are touching.